Well, hello everybody. Welcome to the July Python Barcelona Meetup. We will start with David Arcos and Efficient Django. If the second speaker is around here, because I don't know him, just raise your hand. No? So, great. So, for now we have one talk, Efficient Django by David Arcos.
I can do the talk twice.
So, let's start. Give an applause to David.
So hi, thanks for coming here. This is a talk I gave at EuroPython last week, and it's about Django, performance, and scalability. So we will see some tips, tricks, best practices about how to avoid scalability issues on your Django application and how to improve the performance. This will have four parts. First, we will see the theory, the basic concepts, the most common things. Then we will go to monitoring. We will measure our application and find the bottlenecks. And at third, we will see some best practices, tips and tricks on how to fix some existing problems with scalability and performance. And finally, the conclusion, of course, it scales. Spoiler. So this is me, I'm David, I'm a Python and Django developer since a lot. I'm co-organizer at the Python Barcelona Meetup, this meetup, so maybe you remember me from other talks. And I'm CTO at Lead Ratings. Lead Ratings, this is a startup I work at. It's a startup in Barcelona, and we do machine learning as a service. So we have a prediction API, and we do machine learning to improve the sales conversions for many customers. So they send us sales leads, customer prospects, and we can evaluate them. We can predict the possibility of conversion, sales, whatever. This is the company, very nice. So first, basic concepts. We will see about performance and scalability, okay? But first, the Pareto principle or the 20-80 rule. This rule, this is very common, and this says that 80% of the input explains 20% of the output. So in our case, an example with performance, 80% of the time will be spent by 20% of the lines. Okay? So what do we see here? That we have to focus and prioritize a lot on the important things. We should not try to improve the performance of everything. We should not optimize everything, but only the parts we need to. Okay? So, yeah. The trivial tasks, you can take a lot of time doing this, but it won't improve a lot. It's just minor things. But if you can fix the vital ones, you can improve a lot the timings and the scalability issues. So the obvious question here is, how do we find these ones? Okay? So let's focus on these tasks to have the most impact in our application. Scalability. Scalability is defined as a system that can handle more load just by increasing the resources. So you don't need to change the architecture of the system, okay? And the basic tips are to do stateless app servers, so your application is in servers that don't have state, and keep the state on a database, centralized into a single point. You do this, it's very easy to escalate the application servers because they scale horizontally. You can you just add more machines and it scales. And the database, well, that's another story. This is the difficult part, okay? Because the database will have the more complexity, and each database, each system, each platform is different. And usually you will have more than one database, SQL, NoSQL, whatever. But if we do this, we keep the complexity contained at one place. How to improve the performance? Yeah, this one was easy. Less requests and faster requests. We will see how later. So if you do less queries to the database, less reads and less writes, it will go faster, of course. And if you do less requests, because you don't need so many requests, or you can group them in somehow, of course it will be faster. And some tips for this is to add indexes or to normalize the databases. We will see this later. What else? The templates. In Django, we have the templating system, which is very complete and has very good documentation. So for templates, you don't need to do anything big, because usually with the default settings, they are already cached. So cache the templates. You can use Jinja tool that is a bit more efficient than the default templating system. It's more complex, allows for more features. It's a bit faster, but anyways, you have to cache it. Okay, because even if it's faster, the main difference is from caching the templates. Also, in some use cases, in most of the use cases, you won't cache the full template. You will go piece by piece. So in Django, there is a thing called fragment caching, and there you can go fragment by fragment, section by section. The things that won't change, you can set different policies that the dynamic parts. Okay. Cache. So usually the databases, the templates, and the cache are the things that take more time and the more difficult to scale, because if you have more traffic, well, you need to improve these parts the most. Okay, so the cache, it's fine to do a generic approach and cache everything at each layer. So your platform has different layers. You try to cache at the database, at the view, at the template, everything. The documentation is excellent, so take a look. Everything is explained there. You can cache everything. And the big problem here is the caching validation, because you could serve all data not on purpose, and that's difficult. We will see how to fix this later. Okay. So the question here is to cache for everything at all the layers, all the levels, because most of the performance improvements will be on cache. So cache all things. And of course the bottleneck. What's a bottleneck? It's the thing that it's limiting your platform. Okay, the slower part, the broken chain that will make your application go slower. So the difficult thing here is to find the bottleneck. Where is it? What kind of bottleneck? Because if it's CPU bound, you will have to do some things. If it's the memory or the database, you will have to do other things. There is nothing generic about scalability and performance. It depends on your use case. Okay, so try to find the bottleneck. How? Second part, measuring. You have to measure, monitor everything, so you can find the bottleneck, you can find the slow pieces, and before fixing them. You cannot improve what you don't measure. Okay, so measure everything, do metrics. By measuring, you find bottlenecks, then you optimize those bottlenecks, and only those. You don't want to optimize everything again. So just the things that are broken, you fix them. And then, because you are measuring and you have numbers, you can back up and you can verify the claims, the improvements. And you do this many times. So maybe at first the bottleneck is the database, and then you fix it. Then it will be the CPU. You fix it. Then it will be the network processes, and you go fixing thing by thing. But always the thing that takes the most time. And verifying with numbers. Basic monitoring. You monitor the system, the load, the CPU, memory, hard drive usage. You monitor the database, queries per second, response time, size, the cache, how many hits to the cache, how many misses to the cache. The queues, if you have queues for workers, you monitor the length of the queues, because if the queue is growing a lot, then maybe the bottleneck's there and you need to add more workers. And of course, custom metrics for your application. Your own business logic will have some things that need to be measured. They call these things KPIs, but we are developers, so we don't know those buzzwords. Profiling. In Python, we have the C profile module, which is standard and allows you to do profiling of programs. So you just run the program with the C profile, and it will show you some information, the number of calls. So in example, this would be the code in the official documentation. The number of calls, how many times did it call each one. So this one was called four times, but usually you will see here hundreds or thousands of times. Running time, how much time has it been running, in total, per call. You can see here many things. This is quite low level, but this can help you find the thing that is going slow. And the C profile module is perfect for this. Time it. This is another module. This allows you to time the execution time of your script. So you just run Python 3, time it, and this can be a piece of Python, can be a script, can be anything, okay? Yeah, just a method or a snippet like this. And time it will run this code many times, and it will show you the best of those times. So in this example, it's 3 times. Best of 3, yeah, so it returns you the best time. So why? Because usually when you want to set an upper bound on the performance of your application, the best time means that the cache is already preloaded, the CPU is not being interrupted by other processes, and the network is not broken because of whatever. So usually the best time is the best possible time that your application can do, and this is used as a reference for doing the timings. Maybe I'm going very fast. IPDB. This is the Python debugger, but for IPython, the interpreter on steroids, they say. So IPDB is better than PDB. It allows you for some really useful features that PDB doesn't allow you, like tab completion, syntax highlighting, tracebacks, introspection. Just with this line, IPDB set trace, it will stop your program, your script, your application at a point, and then from the shell you can debug. So for example, in your typical Django application, you set a traceback here, and from the Django run server, you run the application, you go to the view, and then bam, it stops. The request will not finish. You will have the code stopped at that point, and then it's like a normal shell. So you can check all the variables, you can keep running the code, next steps, you can see tracebacks, everything. Django-debug-toolbar. Now this is specific of Django, the other ones were generic for Python code. This is specific. How many of you have used the Django-debug-toolbar? Raise your hands. Okay. For the ones who haven't used Django-debug-toolbar, is kind of a sidebar that will open in your application. This is an HTML view, so you will get a toolbar, and if you click any of the panels, you will get more information. In this example, this is info about the queries, but you can see everything. You can see the settings on your project. You can see the cache, if it's being used or not, hits, misses. You can see which templates are being used. You can see almost everything in Django. And the best thing about the debug toolbar is that it's very modular, and you can add more panels. There are third-party applications for the debug toolbar. So, the Django debug toolbar line profiler is a toolbar panel for profiling. So remember this profiling that was very confusing, lots of info, yes, but this is complex to run. You can run it as a panel in the Django debug toolbar. So this means that in the HTML panel you can click the profiling tab, and you will see profiling about your view, your application. You can detect there the slow spots, but just into the browser, into the normal HTML application. And also this is a very nice tool. So the Django debug toolbar and the Django debug panel are very similar. The difference here, the naming is not very good, but the difference is that the debug toolbar works for HTML views. Okay, if you have the typical web application with HTML, you will get the sidebar at your right with everything. But what if you are using API calls? You are using Ajax calls, or you are using, I don't know, other kinds of responses, you are returning a JSON maybe, whatever, that are not HTML. Then the debug toolbar cannot get this code and insert HTML into your view and show it, okay? So this is not a panel, an HTML panel like the others, but this is a Chrome extension. I think it's also in Firefox. You install this extension in your browser, and then you will see in an extension the debug information. So you will see like the other panels, but in your browser. And this is very useful when debugging APIs. And yeah, for Ajax requests and other kinds of responses. And now let's go to the third part. How much time do we have? Yeah, it's going well. So first we saw the basics, the concepts, the theory. Then we saw how to measure, which tools to use to find the bottlenecks and the sweet spots on where to optimize. And now these will be some generic tips and tricks that you usually use in your application, but I insist this depends a lot on your application, because each application will have a different problem. Okay, so let's start by, yeah, this is the most important. Database indexes. If you don't know what a database index is, that's the first thing you should do tomorrow. The database indexes are indexes for the database, and it's the difference between spending lots of seconds or spending milliseconds in doing this query. So, for example, you have a table with 2 million rows, and if you want to do a query that is not well indexed, it will go to all the millions of rows that you have one by one, checking stuff, doing joins, doing counts, doing whatever, and it will take a lot of time. On the other hand, if the database is indexed on that field, it will be very fast because it's already pre-calculated. So it's like an index on a dictionary, or it's like a sorted list. If it's sorted, it's very easy to query. You can have two kinds of indexes, well, more, but those are the basic implemented in Django. Single index by just one field. For example, you have a model with a creation date time. Okay, so you do an index, a single index on the creation field. So it will be sorted by creation, and when you want to do a query by time, by creation time, it will go very, very fast. On the other hand, you can do complex multiple queries. So you can index together more than one field. So an example, if you want to sort by creation time and name, alphabetic order, if you have an index of both fields, the index is already pre-calculated and it will be very, very, very fast. Okay? Things here. Why don't we add indexes for everything always by default forever? Because an index, it takes more space, the writes are slower, it has some handicaps too. Okay, so you should measure, you should use indexes only where needed, only where it's going slow. Indexes, if you have, I don't know, 20 indexes, each time you do a write on the database, it will have to update the 15 indexes. Okay, that's slow. And of course, it will use more space. Nowadays, the space is very, very cheap, but on the database, I mean, that will be a problem at some point. So the tip here is profile, measure, time it. How much time are you spending on the database queries? This is very easy with the debug toolbar or with almost everything. Get the complicated queries, debug them, and find how much time are they taking. And if they take more than, I don't know, more than 100 milliseconds, then there is something very, very wrong, and it will grow a lot. You have 1 million rows, 2 million, 5 million, it will be exponentially more slow. This is an example I had the other day. This is in the Django admin. I had a model with a UUID, a universal ID, sorted by creation time, yeah. And I thought that the order was just creation time, and I had an index on creation time, but it was going very, very slow. It was like 50 to 20 seconds to do just this main query that was like the first or the last 20 objects, okay? It was like 15 seconds more. Then I didn't know why, because the index was there, the creation time index was there, but then by debugging, I found that it was doing the query by both the creation time and the UUID. I still don't understand why. I suppose that Django wants to sort by user ID on the admin because of reasons. Okay, but finding this, okay, it's sorting by two fields. What do I need to do? Index together. I did this and then it was just 2-3 milliseconds, okay? And this was a small table of just 3 and a million rows. Oops. Oopsie. Okay. The DB index field is written in your Django model. In the field, you just add DB index equal true, and the index together is a meta option. So you go to the meta and put index together, and then the arrays of fields you want to index together, okay? But don't index everything because it will take more space. So profile, measure, and focus on the important queries. What else? This also is important. If you can do batch operations, it's faster than if you go one by one. So, an example, you have to ingest from an external database or from a file or whatever you have to create a lot of objects, okay? If you go one by one and you have 1 million objects, it will take a lot of time. But if you can do bulk operations and you can create them hundreds of them at the same time, thousands of them at the same time, it will go much faster. You will earn 2 or 3 orders of magnitude. So you can do the 3 main things: creating, updating, and deleting. Okay? So doing bulk operations reduces the number of SQL queries. The database will have it easier to scale. And also your logic will be simpler, because instead of doing millions of inserts, maybe you will do thousands of insertions and it will be easy. The bulk create object, you just use a list of Django objects before saving them, of course. And this has a handicap. If you do the bulk creation, it will not run the signals. So the signals are like a post-save signal is used you can use them to add fields, to change data, to send notifications to external services. So the bulk creation will not run the signals. You should later do it by hand. Updates, if you have this is a query set, if you have a query set, you can update and say, okay, for all of these objects, set this field as this value. But if you want to do dynamic updates, so if you want to update a field based on another field on the database, until recently with F expressions it wasn't possible. Now it's possible. The F expressions are functions for updating. Well, not only for updating, for getting data dynamically from the Django VM, from the database, and doing, in example, updates and also other things based on those data. In example, I have the model car, and there is a field called wheels. So my car has 4 wheels. If I want to then update and say, okay, for all the cars in my garage, I want to put 1 more wheel, okay, you just do an F expression saying, okay, the current number of wheels plus 1. That's the use case here. And of course the deletion. You can delete all the items in a query set at the same time. Again, update and delete won't run the other signals, okay? A pre-delete, a post-delete will not be run. Same for saves here. More things. This is also for doing less queries on the database. Usually, if you have models, objects related between them, you have to do queries to get all of them. So, for example, you have the parent object, you do a query to the database, and then you have some zones. In example, let's imagine we have a blog, okay, we have a post, and then we have other objects called comments related to that post. If we do it in a naive way, we will do first one query for the post, then another query for the first comment, for the second comment, one by one. With this, you can do, this is for foreign keys and for many-to-many keys. With the select related, this will select all the related fields, the related foreign keys in the same query. So in our example, doing this query set, we would get both the blog post object and all the related comments. Okay? So you do one query instead of potentially thousands of queries. And one query, it will be a bit slower than the simple query, but not slower than thousands of queries. For many-to-many fields, foreign key means relation 1 to n. Many-to-many is n to n. it needs to do an extra query, and it will do the join in Python. So the prefetch related would do. You have the blog post example doesn't apply. If you have objects related to some other objects, and you want to, before doing the main query, it will prefetch the related objects. It will do an extra query. It will get all the IDs, and then it will do the join in Python. So for the main query, it will do the query to the database with all those IDs hard-coded then there in the query. So this will save you, again, hundreds or even thousands of related queries. Orders of magnitude. Yeah, this is nice. The admin, the Django admin can be slow. When you have millions of objects, it will get slow. So what do? We do the previous step. So we do bulk operations, we do related objects, select related, and prefetch related, okay? So, in example, the list select related, this is an option in the admin model. You do the list select related, and then it will do the select related. So, in example, if you have a view, and in each object you want to count the related objects, in example, or you want to show some info, or you want to, I don't know, sort, show the first and the last timestamp, whatever. With this, it will be just a single query. For prefetch related, there is not an option, so you have to override the getQuerySet method. So again, in your admin model, you override the getQuerySet, and inside there, you use the prefetch related. So you have a many-to-many relation. With this, it will be just one query for this and two queries for this, instead of n queries. More tips. If ordering is not using an index, it will be slow, so check. You just use the django-debug-toolbar, go to the admin, check the slower queries, and go for them. So maybe ordering is not using an index. Be explicit when you are doing an admin model. Be explicit, set the ordering so you are sure of what is being sorted, okay? And then you will be really sure that the index is there. And also for the search fields, if you just do a naive search, and it has to go through all the objects in your database looking for a word, it will be very slow. If you index those fields, it will be much faster. Another tip, the with-only fields. This is in the admin, when you open an object, in example, let's say it's a foreign key, okay, you will get a select HTML object. So when you click, you will get all the possible options on the foreign key, and also on many-to-many. This means that each time we open an object, it has to do another query to the other table, get all the objects, and put them there. That takes a long time, and also if you have millions of objects, of possibilities in the foreign key, well, HTML is damn slow, and it will be very slow, and maybe your browser will even crash. So use a wet-only field, and then it will not do the extra query, and it will show just only your foreign key value, okay? On the other hand, sometimes you really need to edit from the admin this foreign key, so that's the next tip. This is the row ID fields, and this means that instead of having a select box with all the million possible values, you will have like a search field, and you can write the ID there. You can click a button, and it will do an extra query, open a pop-up, and you can select there. A tip here is that Django Salmonella, it's a bit better than the raw ID fields, the default option, because it shows you more information. In example, if you select an object, a related object, which is ID 1, 2, 3, 4, the raw ID field would show you 1, 2, 3, 4. Okay, what's this? I don't know. But the Django Salmonella would show you the name of that related object, which is much more usable. So if you don't want to remember the IDs of all your millions of objects, use Salmonella. And last tip, in the admin, in the list view, you have all the filters at your right, so you can filter by foreign keys, by choice fields, whatever. And you can extend this template. This is the HTML template, so instead of doing a list, a UL with all the possibilities, all the objects, you can implement it as a select HTML field. So you just click, and then you can see all the options. So if you have many foreign keys, many choices, and you would have, I don't know, thousands of lines at the sidebar, and it's very difficult to go there and find because you have many options with many options each. You can extend the filter to do different things. Some people, what they are doing is to, instead of doing the filters and doing the extra query sets, they do like search boxes, and you can do searches there. But I think this is quite a good option in the middle. Yeah, the cache. And when I talk about the cache, yeah, the cache is difficult, it's complex, you don't know what to cache. Yeah, you cache everything, but you don't know what to invalidate. What if you are caching a database, a table, and the info is not the last version because you wrote on there? Yeah. So Django Cache-a-lot, yeah, this is the real picture, it's super awesome. Django Cache-a-lot is done by the guys from Johnny Cache, it was called. So they did Johnny Cache, which was the standard module on Django, not standard, but the most used third-party module for generic caching on Django. So these guys did this later, and this application is very cool. If your project is typical, you have the typical queries, the typical use cases of, I don't know, web pages with objects, with lists, this can help you a lot. If your project is more complicated and you need to invalidate cache results often, this can still help you because you can extend it to say, okay, don't touch this table, don't do this thing. You can use signals and you can use their API for these things. Okay, so low level, what Django Cache-a-lot does is each time you do a query, it saves it in the cache, of course. But if you write it, it's done at table level. So if a table doesn't have any write, it will be kept in the cache. Once you write to the table, it will invalidate the cache, and then again it will cache it again in the next query. So caching the results from the database is very useful because sometimes inside of the same request you ask the server for a thing, it does stuff, and then it sends this response back. Inside the same request you are going to the database many times for the same thing, and this happens because maybe you are doing it at different layers. You don't know, if you are not debugging and you are not looking at all the queries, it can happen. So this makes sure that at least inside the request cycle, it will keep the cache and it will keep the values there. Okay? And for using this, you just add a pip install Django Cache-a-lot and add Cache-a-lot to the install apps setting. More things. Queues and workers. This is for if you have a lot of tasks that use a lot of CPU, or if you have tasks that take a lot of network time because you are going to an external API to send a post to whatever service, or if you just want to, your response is very slow because you are doing stuff like sending emails or whatever. This means that you can get some slow stuff and put it for later in a queue. So some workers will do this kind of tasks. So examples, you want to do the billing, okay? You want to generate a PDF with the bill to send to the customers. Okay, you don't do that in real time. You do this apart in a batch system later. An example, each time you upload a model, you have to go for an external API, do a post. Each time I upload a new object, an example, well, whatever, I have to post to Slack to show a nice message, oh yeah, we got another customer. Or each time an object is deleted or updated or whatever, you want to go to external services to do things, okay? So this doesn't need to be done synchronously, can be done later. Just add this task to the queue and it will be executed some seconds later. It's not critical usually, and even if it's critical, if you are using Celery, if it's critical, it can be run again later, okay? You can manage around this very easily. So these operations, you have to find them and you have to queue them, you do tasks, and the workers will run those operations asynchronously. For this, I recommend Celery, which is the most used thing for this. Celery is more than enough for the common use cases. If you have some specific objectives, if you have to be very fast, if you have to be, I don't know, if you have a different use case, You can still use Celery. It can be more difficult because Celery doesn't adapt very well, or you could use your own queue system. Okay, you can just use a Redis queue and have a Python process, read the things and do it. But usually Celery is more than enough. You do the login. You have I don't remember the name. There is a monitor for Celery where you can see all the things. Okay. Is usually the best option for starting, at least, where you don't want to spend a lot of time implementing queues services. You just do Celery tasks. Cached sessions. A session is a visit of a user. You keep a cookie, and on the database usually you keep the session. So when the user comes again, okay, it's this user. I had some stuff for him or her. So you don't need to write the sessions on the database. You can use a cache. Why? Because each time a user comes, okay, this is the cookie, let's see the ID, I have to go to the database, I have to do a read. If it's not there, I also have to do a write. That takes a lot of time for each user. You are having 1,000 users per second, so you are going to do 1,000 reads on the database, and that sucks. You don't want to do these kind of things. So you just add a cache. There are two kinds of caches that you can use with oh, by the way, those are links, so you can go for the presentation, click on the links and see the documentation. With the session engine, you can choose many backends, but usually you have two use cases. If the sessions are not non-persistent, you use a backend that doesn't hit the database. It's kept on the local memory, on Redis, memcache, whatever. But if the sessions are persistent, it will cache the reads but not the writes. Okay, so each time a new user goes there, it will cache it for a while, but after a second or something, it will write all the sessions in a batch. What's persistence? If in my service the user is logged in, and then this machine dies, and then the user goes to another service, the session will be broken, and the user will have to log in again. Okay, sometimes you want to flash all the sessions to force them log in again. So depending on the use case, you use persistent or non-persistent. Usually non-persistent is more than okay, because if you have a problem, having the users logged out and having to log in again, it's the lesser of your problems. More things. Persistent connection. This is also a very easy tip. This is a setting in Django, connection max H. You have to do many connections to the database, and each time it has to open and close the connections. You will have an overhead per connection, because it has to instantiate a new one. So with this you will say, okay, open the connections, but keep them open for 5 minutes or an hour or whatever. So the connection will be kept open, and the next time you have to do a query, it's already there. You can reuse the connection. You don't have to instantiate a new connection as the database. Okay, the channel is already open. How much time should you put there? It depends. A minute is perfect by default. By the way, by default this option is set to 0. Why? Because of backwards compatibility. Because at the beginning Django didn't have persistent connections, so the connection max H was 0. But right now, doesn't make sense to have new connections open all the time. So set this to whatever. A minute is more than enough. You can use infinite connections if you put true or something like that. But you don't want to do that. Why? Because if you have some kinds of bugs, could leave the connections open forever until you reset the machine or whatever, and that sucks. If all the connections are spent, the database will not allow to open new connections, and then you have a big problem. So just setting some minutes, 1 minute, 10 minutes, 1 hour, so in case there is a zombie connection there, it will die after some minutes, and that's more than okay. Opening a single connection is not a lot of time. The thing is that you don't want to do that inside the request cycle, okay? And yeah, just set this setting. More stuff. Okay, this is not very related to typical scalability and performance, but this is important when you want to scale your application and your logic. universal, unique identifiers. By default, in your databases, when you add a model, you will have a standard incremental ID. The primary key will be an ID, so the first object is 1, the second 2, the third 3, and these are your IDs, okay? This sucks. This works very well at the beginning, but at some time, when you want to do sharding, when you want to have several instances, when you want to do some other things, this will be a point of pain. So from the beginning, let's better use UUIDs instead of incremental IDs. UUIDs, the uniqueness is guaranteed. Okay, the possibility of having a UUID of 64 bits collide with another one is there is no chance to happen, okay? But even if it happened, the database would say, oh, the primary key already exists, so your data will not be corrupted. So you avoid collisions. If you had typical primary keys and you were adding objects in 2 instances and the database was partitioned, that can happen when you have distributed databases. If your network is partitioned and yeah, I added the object 25 and I added the object 25 too. Good luck with that. Okay, if your machines are, for example, if you have Internet of Things thingies and they get split from the network and you use primary keys, yeah, that's funny. So always use UUIDs. It will be easier to scale on your logic later. Also, they are very well indexed. In MySQL and Postgres, they have native UUIDs fields since some years ago. So it's not storing a string of text; it's storing a binary object, a UUID that doesn't take a lot of space, and it's like a hash. Okay, so it's not slow. And that will be for easier DB sharding later when you need it. But even if you don't need it, it's a best practice to have IDs that are not consecutive. In example, a competitor would go to your page and say, okay, how many users do you have? I will register a new user and I'm ID 45. Okay, so he has 44 users. Okay, so this can improve a bit the security. Next thing, oh yeah, slow test. What happens when you have unit tests and you are running them and it's very slow and it takes minutes, and all the people in your team are adding more tests and it's slower still, and then you don't run the test because it's so slow. You want to develop, not run tests, and then bugs get through, and then yeah, you know what happens. So if you want to have faster tests, there are a million things to improve. Okay, there are a lot of articles on the internet about this, but these are the main steps for me. So first, you don't want to run the migrations, okay? There is an option since Django 1.9 of keeping the data, 1.8 for keeping the database and 1.9 for running in parallel. In Django 1.7 it was not possible to keep the database, so you had to run all the migration, so you had to do minor hacks to say, okay, don't migrate all of these, but you had to hard code things and it's like. In 1.8, they allow you to keep the database, so you run the test, it creates the database, and the database is not deleted. And you have the last image of the database, and the next time, of course, the data will be deleted, but the schema is there. If you have an application, an old application that you develop a lot, you do lots of migrations, the migrations will take more than seconds, will take minutes in adding everything, okay? So keep the databases, keep the migrations. When you are doing unit tests, you are not testing the migrations. That's more like an integration test. So unit tests should have very clear what they do, and not migrations. And next tip, running parallel. This is really new, parallel. This is in Django 1.9, and before that we had to do, all rampant. We had to do many different hacks to run in parallel with each testing framework had different things, and they were not compatible with each other's plugins, and it was super funny. If you run in parallel, it will go faster, okay? It will segment by test cases. So if you have 10 test cases and you run in parallel, maybe 4 in parallel, it will be much faster, of course. By default, parallel will take, I think it's the number of CPUs plus 1, something like that. So it's already intelligent enough, so you just add, when you are running the test, add keep DB parallel and these things, and that's it. Now, it's very common to have specific settings for the test. So when you run the test, .py keep DB parallel test, and you use a different settings file. Okay? If you have a different settings file, you can do some improvements, hacks, optimizations, whatever, so it's faster. In example, your application can have a ton of middlewares. Middlewares are very slow because middlewares are in the middle of the request. So disable the middlewares you are not testing. If you are testing a single application, you don't want to test all the middlewares of the other applications. And you will test those in the application with the middlewares. Remove the installed apps you are not using. This doesn't help you a lot because this will take just some memory. But if you had slow apps, this could be a lot of time. Okay, so remove everything you are not using. Go to the settings and password hasher, use MD5, login, disable everything you don't want to. Just remove stuff. It will be faster in an easy way. And this is the low-hanging fruit. Okay. Also, use mocking whenever possible. If you are doing unit tests, you should always use mocking because you are not expected to go to external services or to go even to the file system or to a database to do stuff because you are testing your own logic, not the third-party logic. Okay, so if you are not doing it right, if you use mocking, it will go much faster because a mock, I don't know, an example, I want to upload a file to Amazon S3, to the CDN. If I use a mock, that's instant. If I don't use a mock, it will go to Amazon, upload a file, and then delete or whatever. It will take some time. It will put garbage in your CDN, and it will be very slow. Usually when you do test, you will be uploading thousands of files, so this takes a lot of time very easily. How much time do we have? Do you have the second speaker yet?
Yeah. So, carry on.
Okay. Sorry. Yeah. Oh, perfect. So conclusions. After all of this, okay, I would like you to remember some minor parts. First thing, monitor, measure, numbers. You want metrics. You want to see what's happening. If you have numbers, you can detect the bottleneck. If you can detect the bottleneck, you can optimize. You can fix the bottleneck. Go for the easiest things to fix. Okay, go for those 20%. Maybe for the 1% that takes more time. And measure again to make sure that the improvement you did is going faster. If you add an index, be sure how much time did it took and how will it take later. And you put that in your commit, your pull request or whatever. Okay, this improvement makes this and this. Those kinds of improvements. And these are the conclusions. Measure a lot, optimize only the bottlenecks, and rinse and repeat again and again and again. Some good resources. Go to the slides and click here. So the official Django documentation, of course, it has very good information on performance and on database scalability, specifically. So if you follow that, you will see most of the concepts here. So I didn't invent anything. This book, High Performance Django, this is like the best book when you want to do real Django projects in production with lots of users, bigger things. So this book tells you everything. It's a bit old and some things are outdated, but for most of the case, this book will explain how to do high performance, but not only from Django, but outside of Django with other tools. Okay, so in this talk I focused on Django only, on the things you can do from Django, but on this book you will get an example how to use engines with a proper configuration, how to use varnish, how to different databases, how to configure these kind of things Django is in the middle, but all those other things are very useful. And it will also tell you what middleware to use, how to improve templates, whatever. Very good section on the caches. Also, this blog, Instagram Engineering. Why Instagram? Instagram has the biggest Django platform out there. Okay. So they post real numbers and real use cases, and I mean, if they have the biggest thing there and it works very well, we have to listen to them. Okay, they have another blog. This is a Tumblr, but it's a blog, right? They have another one for data science, Insta Science or that Instagram, something like that, which is also very, very cool because they have huge problems and they have to solve them in a really big data way. And with this engineering, when Facebook bought Instagram for I don't remember how many millions, they had like 3 backend engineers. So yeah, listen to them. Also, this link, this is very important, or Google this. Latency numbers, every programmer should know. We should have a tattoo with this on us. These numbers, do you know how much time does it take to go to a local file in the file system to open a file to read 1 megabyte? To do the same in a network, to do the same in memory, in the cache, in the LTU cache, in the CPU, a hit, a miss, whatever. You have all kind of numbers here. And of course, you would say that the file system was a tricky question because actually it's faster to go to a different machine in your data center than to go to the hard drive. And these kind of things are not very intuitive, but if you have a good network and your machine is on the same building or data center, the connection is much better than going to the hard drive because the hard drive has a big overhead. At what point it's better to go to the hard drive? If you have to get a lot of megabytes, the overhead of going to the hard drive is for the first time and then it will be better. With these numbers, you can calculate very easily and you can do some numbers of how many machines do I need to provide the service for 1,000 users or 100,000 users or millions of users. So take a look at this. We should know this very, very well because if we don't have the numbers, we cannot really design platforms and systems in a proper sciencey way. So thanks for attending. Get the slides there. I will tweet them. They will be posted in the PyBCN Twitter account. We are looking for engineers, data scientists in lead ratings. So if you are looking for opportunities, maybe talk to me later. Yeah, thanks for attending. Any questions? Yeah.
I have time for a couple of questions. Yes, I have a question. In my understanding, or maybe misunderstanding, I see many people thinking that Django is for web applications and not for APIs. Now I see that in lead ratings, your main product is an API. Can you tell us a bit how you included the API into the Django ecosystem?
Yeah, no, in Django you have the main libraries, okay, and then many third-party libraries. So the main libraries, the ORM, an example, I mean, doesn't matter if you have an API or a web application, right? The admin doesn't matter if it's a web or if it's any kind of application. Most of the things, okay, the templates, of course, are for web. But I mean, I'm not using I'm using templates for the admin because I'm customizing the admin, okay? But if you have, you have a single API, a simple API, and you don't want to add lots of features, and you say, okay, let's go for Bottle, Flask, or any other micro framework, okay, that's cool. But if this API has to grow, if you have to add some other layers, if you want to add cache, you want to add authentication, you want a dashboard to show everything, you want things and things, then they say that if you don't know Django, you will re-implement Django again, and that happens to some people. So if the API is very small, yeah, use any kind of framework, but if it has to grow, if your API needs to have an admin, like the Django admin, I mean, it's very easy. Does this solve the question?
Yeah.
I mean, in APIs also check Django REST framework, which is a framework for REST API, which is literally the best thing in Python to happen for APIs, and in Django it's very well done. The guy doing it he did a Kickstarter or something like that, so he has a salary paid by a lot of companies to focus on this, and it's really, really nice.
Yeah,
so it depends on your case. More questions?
I have one.
Yeah.
Regarding the use of Celery, well, we know that Celery is not asynchronous, it's just a queue. So in Python 3.5 now is this function async IO. So someone knows that if this, I mean, Django is going to take advantage of this. I mean, because against another frameworks, for example, the ones from JavaScript, they go asynchronous out of the box. So what about Django? Is taking, someone knows that it's taking advantage of these functions?
Can I troll about the JavaScript part?
Okay.
Up to you.
No, I'm
See you
Pythonist.
later,
I'm
sorry.
Pythonist.
Yeah,
The thing
so
that
no, of course, Celery is supposed to run synchronously because at some point you want to keep track of the resources. What you're asking for will happen in Django 2.0. Okay, it's already in the 1.10 or 1.11, the alpha. This thing is called Django channels. So the channels are for asynchronous things. So for example, you have a WebSocket. There is no support for WebSockets right now for Django. I mean, that sucks. So what they did is that the very intelligent minds, they thought a way of doing this in a proper way. So you can do applications like chat, like real-time things, WebSockets, these kind of things, from Django. So the server, instead of being a typical synchronous server, will be more asynchronous.
like twisted.
On the other, yeah, like Twisted, but with async AO, with Python 3 and these things. They already backported this into, I think there is a standalone application for even for Django 1.9 called Django Channel, so they backported this so you can start testing, but from Django 2.0 it will be baked in the main thing. This is why they are changing the measure, okay, 2.0, because of the channels architecture, because this means that they have to change everything to accommodate to this. If you want to do a typical synchronous application, it will not be a big change, but it will allow you to do these kind of things, asynchronous things. On the other hand, if you have a worker system and you want to execute things, and maybe you don't want to execute thousands of things at the same time, because the resources are constricted, so it depends on your use case. For the generic case, I agree with you, it would be faster to be synchronous. But if I want to do these low jobs later in a queue system, I don't want to open 1,000 jobs at the same time if this is keeping the performance on my main query. So I want my API to be fast. And in an example, a user uploads an image, okay? I save the image and I get a task for later, okay, do 10 thumbnails, Facebook does this. Do 10 or 20 thumbnails with this image. I want to do this later, asynchronously, but I don't want this to take a hit on the performance. So it really depends.
Okay.
Okay, more questions?
We have time for one more question.
But not for JavaScript people.
Fine. I have another question regarding...
No, you don't ask questions.
Why?
Let's go on. Anyone else? Yeah.
Question.
You already asked.
Okay, I was thinking, regarding the asynchronous stuff, one thing I noticed from your talk, and also one of the most one of the biggest bottlenecks is database queries, and the fact that they are blocking. So if you want to do like 3 queries, you have to do 1 query, wait for it, and then wouldn't it be cool if you could in some way queue up all these queries and put them in a synchronous way, I mean in a concurrent way, so you don't have to wait every time for each query and you can do all the same at the same time. I don't know if channels can solve this, or you will need to add some, I imagine you need to add kind of driver for SQL that is asynchronous and then just...
Yeah, no, it's not done in channels. There was a project some years ago to do more or less this, and they had very clever people doing that, but at the end they implemented it, but it was not faster. So they said, okay, let's drop this. Why it's not faster? Because databases, the typical databases, the good ones, not the MySQL hipster ones, they are already optimized for more than 20-30 years for this kind of use case. Okay, lots of reads and writes at the same time. They are already optimized for this. If you want to do asynchronous databases, some people have tried this, also outside of Django, of doing it more asynchronously, but at the end, you don't get a bigger performance because they are not for batching, they are for asynchronous things, all of them at the same time. So theoretically, yes, you could improve, but the database are already tuned for these use cases, lots of writes and reads at the same time.
Wait. If you have 20 millisecond query, you issue it, you wait for it, and then 20 milliseconds. In this time, you will be doing some other thing, some other code, and then later back you get the result and continue doing stuff. I don't know if many, because every time I read about asynchronous Python, they say, okay, the I/O is the most time-consuming thing, and it's wise to try to do this do a lot of queries and get all the results as they come, and then just continue.
I think it was like 2 or 3 years ago when they were doing lots of things with async AO. What they did was to write asynchronous connectors for the database. Okay, so instead of using the standard connectors, they did really asynchronous ones. And then after the benchmark, yeah, for one query it's faster, but when they did the benchmarks, it was worse than doing it in the typical way. Why? Because it's already optimized for that. It's expecting, so the database is not idle. So maybe your application will go faster because you are not using that time, but the database will not be idle. It will be doing other things or improving indexes or I don't know why. But they did the numbers and having asynchronous connectors to Postgres, I think it was, and to some other ones, didn't make sense. So maybe in the future, I don't know. More
Okay.
questions? No?
Let's go after David. We'll make a 5-minute break, so take some fresh air and come back in 5 minutes.